In this video, we will learn how to find the standard deviation for a sample using Geogebra, as well as calculate values that are a certain number of standard deviations either above or below the mean. The example says, in a 5th grade class, the teacher was interested in the average age and the sample standard deviation of the ages of her students. The following data are the ages for a sample of n equals 20 5th graders. The ages are rounded to the nearest half year. And we have all of the ages here. Now we need to enter these into Geogebra. Since we are dealing with one variable, just the age of students, we can enter those into one particular value. What we will do is define some letter or some word. In this case, I'm going to use age. And then I will press the equals button. And then I will press F of X to bring up the set brackets or the curly brackets. And from here, I'm going to enter all of the data values. But since I can do this from my screen, I will just copy and paste all of these data values. If you are not able to do that, totally fine. Pause the video now and enter these data values in. All right, so once you have them entered in, you can press enter, and that will define the variable age as the given data values. From here, we want to calculate the average age, or the mean. Since they tell us that this is a sample, we will use the sample mean, x bar, and we will find the sample standard deviation, which is the letter S. All right, so in Geogebra, we can calculate the mean by typing in MEAN, open parentheses, of either the data or the variable. As you noticed, I am not a fan of using the drop-down menus in Geogebra. There's nothing wrong with them, it's just I find it a little bit easier to type them in. And then from here, we can find the standard deviation of the variable. We can find the standard deviation by typing in STDEV. Now, again, I'm not a huge fan of the drop-down menus, but there are two different options. The first one is for a sample. The second one is for a population. Since we are dealing with sample data, we're going to use STDEV, open parentheses, and then type in the word age, or whatever variable we've used to define our variables. Or if we want to, we can just type in all of the ages here, 9, 9.5, 9.5, so on and so forth. Press enter, and we get the sample standard deviation is 0.716. We can go as many decimal places as we want to, but in this case, 3 should be fine. Our mean is the 3 place value, so our standard deviation will also be the 3 place values. Now from here, the second part of the question says, what are the ages of students that are within one standard deviation of the mean? So what we will do here is take the mean value of 10.525, and we will add one standard deviation to it to find the age that is one standard deviation above the mean. Age that is one standard deviation. Oh, my pen does not want to write in the bottom corner of my screen. Bear with me one second. One standard deviation above the mean. And then we will take the mean and subtract one standard deviation from it. And that will give us the age that is one standard deviation below the mean. age that is 1 standard deviation below the mean All right, so here's what we're going to do. We are going to take the mean, 10.525, and we will add 1 standard deviation to it. Now, since this is just 1, we don't really need to do that 1 times multiplication. We can just do 10.525. Oops. Let me enter and go into a new entry. Why is it doing this? I'm going to go down here. 10.525 plus 0.716. Technically, we also could do A plus B because we have A as defining our mean and B defining our standard deviation. And either way, we'll get 11.241 or 11.2408, which would round to 11.241. Now, the nice thing about Geogebra is that I could duplicate the input and instead subtract. Just in case you missed that, I just clicked the 3 dots on the right side, duplicate input, and you can do this for anything you want to. In this case, we can change the addition to subtraction, minus a B, press enter, and this will tell us the age that is 1 standard deviation below the mean. So we take 10.525 minus 0.716, and we get 9.809. So that is how to calculate the mean, the sample standard deviation, population standard deviation, as well as the ages that are 1 standard deviation above and below the mean.